Before modern humanity claimed dominion over the planet, a different kind of human walked the frozen landscapes of Ice Age Europe. They were the Neanderthals, and for over 300,000 years, they thrived in conditions that would break most people today. If you're using these to fall asleep, that's why I make them, so subscribe maybe. Tell me where you're at in the time. Comments are like, Berlin at breakfast, Boston at bedtime, all at once. The skeletal remains found scattered across Europe and Asia tell a story that scientists are only now beginning to fully understand. These weren't primitive brutes stumbling through the darkness. They were survivors, innovators, and perhaps most surprisingly, they were human in ways that would challenge everything we thought we knew about our own species. In the windswept valleys of what is now France, in the limestone caves of Spain, and along the coastal cliffs of Britain, evidence has emerged that paints a completely different picture of Neanderthal life. Recent excavations have uncovered something remarkable. These ancient people possessed capabilities that rival, and sometimes exceed, those of our own ancestors. The first Neanderthal fossils that came to light in the 1800s sparked immediate controversy. Victorian scientists, looking at the heavy brow ridges and robust skeletal structure, declared them to be little more than cavemen, intellectually inferior and culturally barren. This view persisted for over a century, embedding itself deep in popular imagination, but the fossil record was hiding secrets that would eventually force a complete reassessment. When you examine a Neanderthal skull closely, what strikes you immediately is not primitiveness, but adaptation. The face is distinctive, pushed forward in a way that seems almost alien to modern eyes. That prominent nose, those massive nasal cavities, they served a crucial purpose in the frigid world these people inhabited. During the depths of the Ice Age, winter temperatures across Europe plunged to minus 20 degrees Celsius and colder. The landscape was a harsh mixture of frozen tundra and scattered patches of hardy vegetation. Sea levels dropped dramatically as water became locked in massive ice sheets, exposing vast territories that are now submerged beneath the English Channel and the North Sea. This was the world Neanderthals called home. Professor Chris Stringer has spent decades studying the physical characteristics of ancient humans at London's Natural History Museum. His research reveals something fascinating about Neanderthal facial structure. The enlarged nasal passages weren't just random evolutionary quirks. They were sophisticated biological radiators, warming and humidifying the intensely cold air before it reached sensitive lung tissue. Every breath in that frozen environment could have damaged their respiratory system without this adaptation. Their entire body reflected this cold weather engineering. Neanderthals possessed barrel chests housing enormous lungs. They needed to process huge volumes of oxygen to fuel bodies that burned calories at an extraordinary rate just to maintain core temperature. Their limbs were shorter and stockier than ours, reducing surface area and conserving precious heat. Every aspect of their physiology spoke to hundreds of thousands of years of natural selection in brutal conditions. But physical adaptations alone don't explain how they survived. Neanderthals developed something that would prove equally crucial to their success. They became master toolmakers, developing techniques that represented genuine technological breakthroughs. The method they perfected is known to archaeologists as the Levallois technique, named after a 19th century quarry in France where examples were first recognized. This wasn't crude rock banging, it was precision engineering with stone, requiring an understanding of geology, angles, and force that took years to master. At archaeological sites across Europe, researchers like Vincent Lassuer have reconstructed these ancient manufacturing processes. The technique begins with careful selection of the right kind of stone, usually flint, which fractures in predictable ways. The craftsman shapes a core, preparing its surface with deliberate measured strikes. Then, with a single precise blow, they detach a thin, sharp flake with a cutting edge that rivals modern surgical steel. Each levallois point required planning several steps ahead. The toolmaker had to visualize the final product inside the rough stone and work backwards to create it. This demands cognitive sophistication that speaks to planning abilities, spatial reasoning, and technical knowledge that had to be learned and taught across generations. These weren't disposable tools hastily made and discarded. Neanderthals invested time and skill into creating implements that would serve them well. Sharp stone points could be hafted onto wooden spears for hunting. Scraping tools processed animal hides into clothing and shelter materials. Cutting implements allowed efficient butchering of large prey. The Levallois technique gave Neanderthals a technological edge that helped them spread across a vast territory despite environmental challenges that would have defeated lesser adapted populations. As climate fluctuated between glacial and interglacial periods, Neanderthals demonstrated remarkable flexibility. When temperatures briefly warmed and forest expanded, they adapted their strategies. When the ice returned and tundra reclaimed the landscape, they shifted again. This adaptability suggests something important about their cognitive abilities. On the island of Jersey in the English Channel, archaeologists have been investigating one of the most important Neanderthal sites in Europe. La Côte d'Estrade has preserved over 200,000 years of human occupation in its sediment layers. Dr. Becky Scott from the British Museum leads research at this extraordinary location. The site captures environmental transformations that occurred over immense time spans. During warm interglacial periods, Jersey enjoyed a climate similar to today's, with the sea nearby and temperate forests covering the landscape. During glacial phases, the island became part of the continental mainland as sea levels dropped dramatically. The climate turned Arctic, and vast frozen plains stretched north for hundreds of kilometers where ocean waves roll today. Through all these changes, Neanderthals kept returning to this place. The sediments reveal their presence during both environmental extremes, suggesting they possess strategies for survival across radically different ecological conditions. The landscape of Ice Age Jersey would have looked completely alien to modern visitors. Where tides now cover the bay, there once stretched a vast plain cut by river valleys and dotted with features that made it ideal hunting territory. Bathymetric surveys of the modern seabed conducted by Richard and Martin Bates revealed buried canyons and natural choke points where prehistoric hunters could have ambushed migrating herds. Rising above this ancient plain was a towering rock formation that still dominates the modern island. Professor Stephen Mithen from the University of Reading has studied how Neanderthals might have utilised this natural vantage point. From its summit, hunters could survey enormous stretches of territory, spotting herds of mammoth, bison, or horses long before they arrived. This kind of strategic use of landscape demonstrates planning and coordination that requires sophisticated communication. The Neanderthals who used La Côte weren't just passing through. They understood this landscape intimately. They knew where animals would migrate, where water could be found, where the best stone for tools existed. This was their territory, and they had learned to extract maximum benefit from it. Evidence from the site reveals something else crucial about Neanderthal society. The flint used to make tools at Lacotte didn't come from Jersey itself. There are no flint deposits on the island. Instead, the stone had been carried from sources 20 to 30 kilometres away in areas that are now parts of France's Channel coast. This might not seem significant until you consider what it means. Neanderthal groups were making deliberate journeys to known flint sources, extracting material and transporting it back to places like Lacotte. They carried toolkits with them across the landscape, working the stone as they travelled, creating implements as needed. This represents mental mapping of territory, planning of movement, and logistical thinking that goes far beyond simple opportunistic foraging. On the northern coast of France, another crucial site has revealed even more about Neanderthal hunting capabilities. Cahors preserves evidence of hunts that occurred approximately 123,000 years ago, during a warm interglacial period. The French National Institute for Archaeological Research has been excavating here for over a decade. Jean-Luc Locht directs the excavations. His team has uncovered something remarkable. The site sits near an ancient riverbank where the ground would have been soft and muddy. Large animals approaching to drink would have found themselves struggling in difficult terrain. Neanderthal hunters apparently recognized this tactical advantage and exploited it repeatedly. The bones recovered from Cahors tell a story of successful big game hunting. These weren't small, easy prey animals. Neanderthals at this site killed enormous wild cattle nearly 2 meters tall at the shoulder. They brought down woolly rhinoceros, animals that were both huge and notoriously aggressive. They hunted various species of deer and reindeer with apparent regularity. Before Cahors was excavated, many experts believed Neanderthals couldn't adapt to warm, forested, interglacial environments. The prevailing theory held that they were specialized cold-weather hunters who retreated south during warm periods. Cahors demolished this assumption completely. Neanderthals weren't environmental specialists locked into one ecological niche. They were generalists who mastered multiple environments across their vast range. This site reveals careful organization of activities across the landscape. The animals weren't being butchered where they were killed. Instead, carcasses were transported to specialized processing sites, like the one at Cahors. After initial butchering, meat was probably carried to base camps located at strategic distances. This kind of spatial organization of tasks shows planning that extends through time and space. Tool production at Cahors reflects this same efficient mindset. The flint implements found at the site were made quickly and functionally. There's no excess elaboration, no wasted effort. The goal was to have sharp, effective tools when they were needed for specific tasks. After use, they were apparently abandoned as Neanderthals moved on to the next stage of their seasonal rounds. Analysis of the site's stratigraphy reveals patterns of occupation. The oldest layers show visits twice per year, probably coordinated with animal migrations. Later levels indicate longer stays, up to 10 months at a time. This suggests Neanderthal land use patterns changed over time, perhaps in response to shifting environmental conditions or changes in prey behavior. What emerges from sites like Cahors and Lacotte is a picture of people who moved purposefully across their territories. Neanderthals were nomads, but not in the sense of aimless wandering. They travelled established routes between locations that each served specific functions in their annual cycles. The territories they occupied were substantial but not unlimited. individual groups probably ranged across several hundred square kilometers, moving between hunting grounds, tool-making sites, and seasonal camps. Within these home ranges, they knew every useful location, every reliable water source, every place where certain plants grew or animals gathered. Population density across Ice Age Europe was remarkably sparse. Estimates suggest that at any given time, only a few tens of thousands of Neanderthals inhabited an area the size of modern Europe. Groups were small, probably 20 to 30 individuals forming extended family units. A large clan might consist of 2 or 3 such family groups maintaining contact with each other. This scattered small group structure had profound implications. With so few people spread across such vast territories, the challenge of finding mates outside your immediate family became significant. Genetic diversity requires regular exchange of individuals between groups. Without it, populations can spiral into inbreeding and eventual extinction. Evidence from sites across Europe suggests Neanderthals solved this problem through periodic gatherings. At certain locations, multiple groups would converge, probably on an annual or seasonal basis. These weren't random meetings. They appear to have been planned assemblies at traditionally significant places. In southern France, the Grotte Mandarin cave system sits along the Rhone River Valley. Dr. Ludwig Slimak has been leading excavations here that have revealed something extraordinary about Neanderthal social organization. The cave faces north toward where the Mistral winds blow down from the mountains. Over 120,000 years, sediments accumulated inside, creating a layered record of human occupation that extends from the earliest Neanderthal presence to their final disappearance 42,000 years ago. The pattern of occupation at Mandarin is striking. Neanderthals didn't live here permanently. They came for brief periods, sometimes just a few days, then departed. But they kept returning, generation after generation, over tens of thousands of years. There are gaps in the occupation layer spanning decades when no one visited, followed by renewed use. This pattern suggests Mandarin served as a meeting point on a circuit of seasonal movements. Different groups travelling through the Rhone Valley would stop here, perhaps leaving markers or messages for others, perhaps timing their visits to coincide with gatherings of multiple clans. Research at the Cedron Cave in Spain provides additional evidence for these social networks. Analysis of Neanderthal remains there indicates that women move between groups, probably as part of mate exchange systems. This makes evolutionary sense. In small populations where everyone in your group is a close relative, you need connections to other groups to find genetically unrelated partners. The mechanics of these social networks become visible when archaeologists trace the origins of stone tools. At Mandarin and similar sites, flint artifacts show up from sources located hundreds of kilometers away in different directions. Some pieces came from 300 kilometers east, others from equally distant western sources, still others from far to the north. No single Neanderthal group covered such enormous distances in their annual movements. The ranges are simply too large. Instead, the evidence points to a network of interconnected groups, each with their own territory. When groups met, they didn't just exchange potential mates, they traded tools, raw materials, and information about distant regions. This kind of social complexity requires communication far beyond simple gestures. Professor Stephen Mithan has studied the cognitive requirements for coordinating group hunting and maintaining social networks. He argues that Neanderthals must have possessed sophisticated communication systems. Think about what's required to successfully hunt a mammoth or bison. Multiple hunters need to coordinate their movements, anticipate the animal's reactions, and execute a plan where timing is critical. A hunter who doesn't act at precisely the right moment could get someone killed. Building the trust necessary for this kind of cooperation requires extensive communication. Did Neanderthals speak a language like ours? The question has consumed researchers for decades. We can reconstruct certain aspects of their vocal anatomy from fossil remains. The shape of the skull base, the position of the hyoid bone in the throat, and the configuration of the inner ear all provide clues. Professor Chris Stringer notes that Neanderthal vocal tracts were fundamentally similar to ours, with one possible difference. The voice box may have sat slightly higher in the throat, which would have raised the pitch of their voices. The robust, heavy-featured Neanderthals might have spoken in surprisingly high tones. More importantly, their ear bones show they could perceive the same range of sound frequencies as modern humans. Whatever communication system they used, they had the auditory capability to process complex sounds, including the subtleties of spoken language. But having the physical equipment for speech doesn't necessarily mean using language the way we do. Modern human language combines discrete sounds into words according to grammatical rules that allow us to construct infinite variations of meaning. We can discuss abstract concepts, past events, future plans, and things that exist only in imagination. The archaeological evidence suggests Neanderthals planned ahead, coordinated activities, and maintained social relationships across distances. These capabilities require sophisticated information exchange. Whether they used words combined with grammar the way we do remains uncertain, but they definitely communicated complex ideas somehow. One intriguing possibility is that Neanderthal communication relied heavily on musical elements. Melody, rhythm, and tone convey enormous amounts of emotional and social information, even without words. Before hunting dangerous animals together, perhaps groups sang and danced, building group cohesion and trust through shared rhythmic movement. This might seem speculative, but there's psychological research supporting the idea. Musical activities activate neural pathways associated with social bonding and trust. They synchronize groups emotionally and physically. For people who need to work together in life or death situations without extensive verbal language, music and dance would be powerful tools for creating unity. Evidence for the cognitive capabilities underlying Neanderthal communication comes from studying their brains, or at least the fossil impressions left by brains in the interior of skulls. The shape of a Neanderthal brain case differs noticeably from that of modern humans. The forehead is lower and flatter, the skull is longer from front to back, and more rounded when viewed from behind. Strong brow ridges shelter the eye sockets. These differences might suggest different brain organization, but skull shape doesn't necessarily reveal mental capacity. Neanderthal brains were actually slightly larger than modern human brains on average. Size alone doesn't determine intelligence, but it indicates they had substantial neural tissue to work with. Dr. Mithan makes an important point about cognition that goes beyond pure brain anatomy. Intelligence isn't just what's inside your head, it's also what's around you. Human intelligence today depends heavily on external supports, like written language, mathematical notation, and accumulated cultural knowledge. We're not particularly clever without our tools, books, and technology. Neanderthals had large brains, but apparently limited material culture to scaffold their thinking. They made effective tools, but those tools didn't change much over hundreds of thousands of years. they left no clear evidence of symbolic art, notation systems, or elaborate decoration. Without these external cognitive supports, their mental capabilities might have been inherently limited despite having brains as large as ours. Yet some archaeological findings hint that we might be underestimating Neanderthal cultural complexity. In the limestone caves of France and Spain, excavations have revealed structures that seem to serve no obvious practical purpose, yet required considerable effort to create. At Brunel Cave in France's Ardèche region, archaeologists exploring deep interior chambers discovered something unprecedented. Over 300 meters from the entrance, far beyond where daylight penetrates, they found circular structures built from broken stalagmites. The pieces had been deliberately snapped off and arranged in rings and piles. Radiocarbon dating revealed these constructions were approximately 175,000 years old. Why would Neanderthals venture deep into absolute darkness, break off chunks of cave formations and arrange them into patterns? The structures weren't defensive barriers. They weren't shelters from weather. They weren't associated with tool-making or food processing. They seemed to represent something else entirely. Some researchers interpret these constructions as evidence for symbolic or ritual behavior. Others caution against reading too much into patterns that might have practical explanations we simply don't understand yet. What's clear is that Neanderthals were capable of coordinating labour to create something that required planning and cooperation. Back at Lacotte on Jersey, Matt Pope has studied similar examples of apparently non-functional structures. In certain levels of the cave, excavators found organised heaps of mammoth bones. These weren't random accumulations from butchering activities. The bones had been deliberately arranged, with skulls placed around the perimeters and ribs driven vertically into the sediment like fencing. The bone heaps create striking visual displays that would have dominated the cave interior. Even if they served some practical purpose like storing material for later use, they went beyond mere function. The careful arrangement, the aesthetic organisation, suggests people were creating something they found meaningful or important. Whether we call this art, ritual, or something else becomes a matter of semantics. What matters is that Neanderthals invested effort into modifying their environment in ways that went beyond immediate survival needs. They left traces of their presence that were meant to endure. At Gorham's Cave on Gibraltar, archaeologists discovered scratches on a rock surface that form a distinct crosshatch pattern. The marks were deliberately carved, requiring concentrated effort with a sharp tool. Dating suggests Neanderthals made these engravings over 30,000 years ago. Journalists nicknamed it the first hashtag, but what the symbols meant, if anything, remains unknown. The marks could be decoration, doodles, or attempts to record information. They could be religious symbols or territorial markers, or they might mean nothing at all to anyone except the individual who made them. Dr. Ludwig Slimak remains skeptical about attributing symbolic thinking to Neanderthals based on ambiguous evidence. He points out that modern humans at the same time period were creating unambiguous symbolic objects. They made jewellery from animal teeth with drilled holes for stringing. They carved figurines and drew recognisable images. In tens of thousands of years of Neanderthal archaeology, nothing comparable has been found. For Slimak, this absence speaks volumes. Modern humans use symbols, decoration, and display to communicate identity and status. These behaviours are fundamental to our social world. Neanderthals apparently didn't engage in these practices, suggesting their social and mental worlds operated differently from ours. The question of whether Neanderthals were truly human like us becomes more than academic when we consider what happened next in their story. Around 50,000 years ago, something changed in the landscape they had inhabited for hundreds of thousands of years. New people appeared, migrating out of Africa and into Neanderthal territories across Europe and Asia. These newcomers were anatomically modern humans, Homo sapiens, our direct ancestors. Their arrival marked the beginning of the end for Neanderthal, though the process would unfold gradually over thousands of years in ways that continue to puzzle researchers. At Grotte Mandarin, Dr. Slimak's excavations revealed something remarkable about the timing and nature of early contact between these two human species. The cave's sediment layers preserve evidence of the first modern human presence in Western Europe, and the story they tell is far more complex than a simple replacement narrative. The earliest modern humans to reach the Rhone Valley came in small groups approximately 54,000 years ago. These initial pioneers brought with them sophisticated stone tool technologies that differed markedly from Neanderthal methods. Their points were smaller, more refined, designed for mounting on projectile weapons that could kill from a distance. But these first modern humans didn't stay. After roughly a decade of presence in the region, they vanished from the archaeological record. The sites they occupied show up in one stratigraphic layer, then disappear. Above those levels, Neanderthal materials reappear, suggesting the original inhabitants returned to territories temporarily vacated. What caused this first wave of modern humans to disappear remains unknown. Perhaps they died out in the harsh European climate they weren't adapted to. Perhaps they retreated south. Whatever happened, Neanderthals continued occupying their traditional ranges for thousands more years without modern human presence. The second arrival of Homo sapiens around 42,000 years ago proved permanent. Modern humans established themselves in southern France and began spreading throughout the continent. At Mandarin and other sites, this wave of colonization is preserved in clear stratigraphic layers where Neanderthal materials give way to modern human artifacts. This time, something was different. The modern humans who established themselves in Europe didn't disappear. Instead, the Neanderthals did. Within a few thousand years of this second contact, Neanderthal populations across their entire range began to collapse. By approximately 40,000 years ago, no definite traces of their presence remain anywhere. Why did hundreds of thousands of years of successful adaptation suddenly fail? What happened when modern humans and Neanderthals met that led to the extinction of one and survival of the other? For decades, anthropologists debated whether the two species ever actually encountered each other, or whether Neanderthals simply died out just before modern humans arrived. The question remained unresolved until geneticists developed techniques to extract and sequence ancient DNA from fossils. The first Neanderthal genome sequence, completed in 2010, revealed something unexpected. Scattered throughout the genetic material were segments that showed unusual patterns. When researchers compared these segments to modern human DNA, they found matches. Neanderthal genes exist in living people today. Everyone of non-African descent carries roughly 2 to 4% Neanderthal DNA in their genome. This genetic legacy could only have come from interbreeding between the species. Not only did Neanderthals and modern humans meet, they had children together. those hybrid offspring survived and had descendants who passed Neanderthal genes forward through tens of thousands of years to the present day. The implications are profound. Neanderthals and modern humans were different enough that anthropologists classify them as separate species, yet similar enough to produce fertile offspring. The boundaries between species, it turns out, can be surprisingly permeable. But if interbreeding occurred, if the two populations were mixing genetically, why did Neanderthals disappear while modern humans flourished? The answer involves demographics, competition, and probably some luck. Professor Tom Hyam at Oxford University specializes in radiocarbon dating of archaeological materials. His research has helped establish precise timelines for the extinction process. What emerges from careful dating of late Neanderthal sites is not a sudden catastrophe, but a gradual fade. Different regions show Neanderthal populations persisting to different times. Some areas seem to have lost their Neanderthal inhabitants earlier than others. Rather than a wave of extinction sweeping across the continent, there was a mosaic of populations hanging on in isolated pockets before finally winking out. During the 2,000 to 4,000 years when both species coexisted in Europe, they must have encountered each other repeatedly. Some interactions apparently led to interbreeding. Others might have been neutral, with groups avoiding contact. Still others could have been hostile, resulting in violence and displacement. Modern humans seem to have possessed certain advantages that eventually tipped the demographic balance in their favour. Their technology was more sophisticated, with evidence of projectile weapons, fishing equipment, and innovations in tool-making that Neanderthals never developed. They created art, jewellery, and symbolic objects that might have served important roles in social networking and communication. More subtly, modern humans might have had larger and more flexible social networks. If they could maintain relationships and trade connections across wider territories, they would have had better access to resources and mates. In times of local scarcity, they could call on distant allies or migrate to new areas more easily than Neanderthals, whose social worlds were apparently more restricted. Dr. Methan points to cultural stagnation as a critical weakness in Neanderthal society. For 300,000 years, they made essentially the same types of tools using the same techniques. The level-way method they invented early in their history remained their primary technology until the end. This lack of innovation suggests their cultures weren't accumulating improvements and discoveries the way modern human cultures did. Modern humans, by contrast, showed rapid cultural evolution. They entered Europe with one toolkit, and within a few thousand years had developed multiple new technologies adapted to local conditions. They innovated constantly, building on previous discoveries to create increasingly sophisticated solutions to environmental challenges. This difference in cultural dynamics might have been rooted in cognitive variations. If modern humans had slightly better abilities for abstract thought, symbolic representation, or social learning, these small advantages could compound over time into overwhelming technological and organizational superiority. Population dynamics also played a role. When species compete for resources, the one with higher reproduction rates and population density usually prevails. Modern human populations seem to have been larger and more numerous than contemporary Neanderthal groups. Even with similar survival rates, sheer numbers provide advantages in competition for hunting territories and other resources. As modern human populations expanded across Europe, Neanderthal territories would have shrunk. Groups cut off from contact with other Neanderthals would have faced genetic problems from inbreeding. small isolated populations are vulnerable to random demographic fluctuations. A few unlucky years of high mortality could eliminate an entire local group. The final Neanderthals probably lived in increasingly marginal habitats, pushed to the edges by modern human expansion. Their populations fragmented into smaller and smaller isolated groups. Eventually, the last communities died out without leaving descendants. Gibraltar, at the southern tip of the Iberian Peninsula, appears to have been one of the final refuges. Gorham's Cave preserves evidence of Neanderthal presence until approximately 32,000 years ago, making it one of the latest known sites. Even here, in this remote corner of Europe, they ultimately vanished. But they didn't disappear completely. Those episodes of interbreeding meant that Neanderthal genetic material got preserved within the modern human gene pool. In a sense, Neanderthals didn't go entirely extinct. They were absorbed. Recent genetic studies have revealed that some Neanderthal genes provided advantages to modern humans and were preserved by natural selection. Variants affecting immune system function, skin pigmentation, and hair texture show up at high frequencies in modern populations, suggesting they helped our ancestors adapt to Eurasian environments. Other Neanderthal genes proved harmful in modern human genetic backgrounds and were selected against. The Y chromosome and mitochondrial DNA of Neanderthals don't appear in modern populations, suggesting hybrid males might have had fertility problems or that Neanderthal maternal lineages died out quickly. What we're left with is a complex story of two human species who coexisted briefly, interacted in multiple ways, and left us with questions that touch on fundamental issues of identity and difference. The Neanderthals were clearly human in meaningful ways. They thought, felt, loved, and struggled to survive in a harsh world. They created culture, made tools, cared for their sick and injured, and buried their dead. Yet they were also different from us in ways we're still working to understand. Their minds might have operated with different strengths and limitations. Their social worlds were organized according to patterns that don't quite match ours. They were human, but perhaps not human in exactly the way we are. The extinction of Neanderthals represents the loss of an alternative path for humanity. If they had survived, the world would be profoundly different. There would be two human species similar enough to communicate but different enough to maintain distinct identities. The philosophical and ethical questions this raises are staggering. How would we have treated them? Would they have had the same rights and status as Homo sapiens? Would there have been cooperation or endless conflict? We can never know, because the experiment ended 40,000 years ago when the last Neanderthal died. What we can say is that we carry pieces of them forward in our DNA. Every person of European or Asian ancestry is partly Neanderthal. Their genes helped our ancestors survive the Ice Age challenges they mastered long before we arrived. In this sense, they're not entirely gone. They live on in us, a ghostly presence in our genome reminding us that human evolution was more complex and interconnected than we once imagined. The study of Neanderthals continues to reveal surprises. New excavations uncover unexpected evidence of their capabilities. Genetic analysis refines our understanding of how our species interacted. Each discovery forces us to revise the story, adding nuance and complexity to what once seemed a simple tale of primitive cavemen replaced by superior modern humans. They weren't primitive, they weren't simple. They were successful for an extraordinarily long time in conditions that would challenge anyone. Their extinction wasn't inevitable or predetermined. It resulted from specific historical circumstances, demographic pressures and perhaps a degree of bad luck. Understanding Neanderthals matters beyond satisfying curiosity about the past. How we think about them reflects how we think about human difference generally. If we can recognize them as fully human despite their differences from us, perhaps we can extend that same recognition to the diversity within our own species. The Neanderthals remind us that humanity has always been variable, that there's no single correct way to be human. Beyond the grand narratives of extinction and genetic legacy lies the question of what Neanderthal daily existence actually felt like. These weren't abstract evolutionary experiments. They were real people living real lives, facing challenges, forming relationships, and experiencing the full range of human emotions. Archaeological evidence provides glimpses into aspects of Neanderthal life that reveal surprising sophistication and depth of feeling. Some of the most compelling discoveries come from burial sites and skeletal remains that show how these people treated each other. At Shanidar Cave in Iraq, excavations during the 1950s and 60s uncovered several Neanderthal skeletons, one of which told a remarkable story about compassion and care. The individual, nicknamed Shanidar I, had suffered catastrophic injuries earlier in life but survived for years afterward. His skull showed evidence of a massive blow that had crushed the left eye orbit and probably blinded him in that eye. One arm had been amputated or withered away, leaving him with only one functional limb for tasks requiring manual dexterity. He walked with a pronounced limp from leg injuries. Despite these severe disabilities, he lived well into his 40s, an impressive age for any Ice Age human. There's no way this individual could have survived alone with such profound limitations. He couldn't hunt effectively, couldn't make tools efficiently, couldn't defend himself from predators. Someone had to feed him, protect him, and care for him over many years. This speaks to social bonds and moral obligations that we typically consider uniquely human virtues. Other sites have revealed similar examples. At La Chapelle-aux-Saints in France, archaeologists found an elderly Neanderthal male who had lost most of his teeth long before death. Eating without teeth in a world without cooking pots or food processors would be nearly impossible. Yet he survived, suggesting others were preparing soft foods for him, or allowing him to consume the most tender portions of kills. These aren't isolated cases. Multiple Neanderthal skeletons show healed fractures, injuries that would have been temporarily debilitating but didn't prove fatal. Broken bones need time to mend. During that recovery period, someone had to provide for the injured individual. This pattern of care for the injured and elderly indicates social structures where compassion and reciprocity played important roles. The treatment of the dead provides another window into Neanderthal emotional lives. At numerous sites across their range, Neanderthals apparently buried their dead deliberately rather than simply abandoning bodies. The graves are simple, lacking the elaborate grave goods that characterize later modern human burials. But the act of burial itself is significant. Why dig a grave for someone who's gone? The behavior doesn't serve any obvious survival function. It costs time and energy that could be spent on tasks directly related to survival. Yet Neanderthals did it repeatedly at sites separated by thousands of kilometers and thousands of years. Some researchers argue burial might have practical origins, removing corpses to prevent scavenging animals from being attracted to living sites. But many burial sites are in locations that don't seem vulnerable to this problem. The simplest explanation is that Neanderthals felt something about their dead that compelled them to treat the bodies with care. This suggests an awareness of death as a permanent state, a loss that affected the living. It hints at emotional attachments, grief, and perhaps even concepts about what should be done for those who die. Whether this constitutes religious belief remains debatable, but it certainly indicates minds capable of contemplating mortality. The physical power of Neanderthals deserves closer attention as well. These were extraordinarily strong people by modern standards. Analysis of their skeletal structure, particularly the bone thickness and muscle attachment points, reveals bodies built for generating tremendous force. Their arms show development patterns similar to modern athletes who engage in intense upper body training throughout their lives. The bones are dense and thick, indicating constant mechanical stress from powerful muscle contractions. The attachment points where muscles connected to bone are heavily built up, showing where massive forces were regularly applied. This strength wasn't just about hunting. Neanderthal lives involved constant physical labour. Processing animal hides into workable leather required hours of scraping and working the material. Butchering large animals without metal tools demanded sustained effort. Moving through rough terrain, sometimes in deep snow, required endurance and power. Their lower bodies show similar adaptations. Wide pelvises and robust leg bones suggest bodies optimized for stability and strength over speed. Neanderthals probably weren't fast runners compared to modern humans, but they could maintain steady movement through difficult terrain while carrying heavy loads. This physical robustness came with costs. More muscle mass means higher caloric requirements. Neanderthals needed to consume enormous amounts of food just to maintain their bodies. Estimates suggest they required between 4,000 and 5,000 calories per day, nearly double what moderately active modern humans need. Meeting these caloric demands in Ice Age environments required exceptional hunting success. Neanderthals couldn't afford many unsuccessful hunts. Their survival depended on consistently finding and killing large prey animals that provided sufficient calories to fuel their energy-intensive bodies. The climate challenges they faced extended beyond simple cold. Ice Age Europe experienced dramatic fluctuations in environmental conditions. Within a human lifetime, landscapes could transform from relatively mild grasslands to frozen tundra and back again. Glacial advances and retreats created constantly shifting ecological zones. Neanderthals somehow maintained populations through these upheavals. When climate shifted, they adapted their strategies. During glacial maximums, when tundra extended far south and forests vanished, they focused on cold-adapted prey like reindeer and mammoth. During interglacial periods, when forests expanded, they hunted woodland species and exploited different resources. This ecological flexibility required detailed knowledge of multiple environmental types. Neanderthals needed to understand the behavior of numerous prey species, recognize edible plants across different ecosystems, and identify useful raw materials in varied geological settings. They accumulated and maintained this knowledge across generations, passing it from parents to children through observation and teaching. The speed at which they could shift strategies when environments changed suggests they retained knowledge about ecological conditions their groups hadn't experienced for generations. When glacial conditions returned after a long interglacial period, they somehow knew how to hunt tundra animals their great-grandparents might have pursued, but their parents never encountered. This implies sophisticated intergenerational knowledge transfer. Elders who remembered previous environmental states might have served crucial roles as repositories of traditional knowledge. Their experience and memory would be valuable resources for younger generations facing unfamiliar conditions. The stability of Neanderthal culture over hundreds of thousands of years now appears in a different light. Rather than indicating mental inflexibility, their cultural conservatism might reflect successful adaptation to unpredictable environments. When conditions are constantly changing, maintaining a broad toolkit of proven strategies makes sense. Innovation for its own sake could be counterproductive if it means abandoning methods you know work. Neanderthal technology, while remaining within the Levallois tradition, did show regional variations. Groups in different areas developed slightly different styles of tool production. Some regions favoured certain point shapes. Others developed specific methods for processing particular types of stone. These variations suggest local cultural traditions being maintained and transmitted. The absence of elaborate art and symbolic objects in Neanderthal sites might not indicate cognitive limitations so much as different priorities. In marginal environments where survival requires constant effort, investing time in creating non-functional decorative objects might be an unaffordable luxury. Modern humans who created cave art and carved figurines often did so during relatively prosperous periods when basic survival was secure. Neanderthals lived their entire existence in Ice Age conditions that were rarely easy or stable. The energy budget calculations suggest they operated close to the margins of sustainability much of the time. Under such pressures, cultural elaboration might take backseat to practices directly supporting survival. Yet they found time for what mattered to them: the bone arrangements at La Cotte, the stalagmite circles at Brunel, the burials found across their range. These represent investments of effort into activities that weren't immediately practical. Whatever motivated these behaviours, they were important enough that Neanderthals devoted scarce time and energy to them. Their relationship with fire shows another aspect of their capabilities. Neanderthals controlled fire consistently across their range and throughout their existence. Fire provided warmth in cold climates, light in dark caves, protection from predators, and means to process foods and materials. Maintaining fire in Ice Age conditions required skill and knowledge. Fuel had to be gathered and kept dry. Fires needed tending to prevent them from going out. The ability to create fire from scratch, whether by striking sparks or using friction methods, demanded practice and understanding of materials. Evidence from hearth sites shows Neanderthals managed fires efficiently. They created structured hearths with stone surrounds that reflected heat and protected flames from wind. They selected fuel woods that burned hot and clean. The placement of hearths within sites shows they understood airflow and ventilation. Fire also enabled technological innovations. Heat treating certain types of stone before knapping made them easier to work and produce superior tools. Some Neanderthal sites show evidence of this sophisticated technique, indicating they understood how thermal properties of materials could be exploited. The preparation of animal hides required fire as well. Smoke helps preserve leather and makes it more supple. Evidence of scraping tools and the location of hearths at processing sites suggest Neanderthals were skilled leather workers, producing durable clothing and possibly shelter materials. In the coldest periods, survival without sophisticated clothing would be impossible. Neanderthals must have created garments that provided effective insulation. This requires not just killing animals, but processing their hides into workable material, cutting and shaping pieces and joining them together. Whether they used sinew for sewing or other methods for fastening remains uncertain, but they clearly had solutions. Their mastery of the landscape extended to understanding seasonal patterns. Archaeological sites show evidence of repeated occupation timed to animal migrations or plant availability. Neanderthals knew when herds would pass through certain valleys, when fish would run in rivers, when particular plants would produce edible parts. This phenological knowledge, understanding the timing of natural events, requires careful observation over years. It means tracking multiple cyclical patterns simultaneously and remembering how they correlate with each other. Groups needed to coordinate their movements to be in the right place at the right time to exploit temporary abundance. Modern scientific techniques continue revealing aspects of Neanderthal biology that would have been unimaginable to researchers even 20 years ago. Advances in ancient DNA extraction and analysis have opened windows into their world that go far beyond what fossil bones alone could tell us. Geneticists can now determine not just that Neanderthals and modern humans interbred, but when and where specific admixture events occurred. The patterns of Neanderthal ancestry across modern populations reveal details about ancient migration routes and contact zones. People in East Asia carry slightly different Neanderthal genetic signatures than Europeans, suggesting separate interbreeding episodes with distinct Neanderthal populations. More remarkably, researchers can identify which specific traits were influenced by Neanderthal genes. Some immune system variants that protect against certain pathogens came from Neanderthals. Genes affecting skin and hair characteristics show Neanderthal origins. Even susceptibilities to certain diseases, including some modern health problems, trace back to this ancient genetic contribution. This creates an unexpected irony. The Neanderthals who disappeared 40,000 years ago still affect human health and biology today. Their genes, preserved through interbreeding, continue shaping our species in subtle ways. They're not truly extinct, just transformed and absorbed into the modern human gene pool. The study of Neanderthals also forces us to confront uncomfortable questions about how we define humanity and what we owe to beings that are almost but not quite like us. If Neanderthals were intelligent, emotional, capable of suffering and joy, did they deserve the same moral consideration we grant to other humans? These aren't merely academic questions. As technology advances toward creating artificial intelligence or enhancing animal cognition, we'll face similar issues. How smart does something need to be before we recognize it as deserving rights and respect? Where do we draw lines between different categories of minds? The Neanderthals existed in a grey zone. They were clearly more than animals, yet not quite the same as us. If we had coexisted, how should we have treated them? Would peaceful coexistence have been possible? Or was conflict inevitable between two similar species competing for the same resources? History suggests humans haven't handled encounters with human difference particularly well. Even minor variations in appearance or culture have sparked horrific violence within our own species. Would we have treated Neanderthals as equals, as competitors, or as something less than fully human to be exploited or eliminated? The fact that we apparently interbred with them suggests at least some interactions were intimate and possibly consensual. Yet the ultimate extinction of pure Neanderthal lineages, while modern humans flourished, implies the relationship as a whole wasn't one of peaceful cooperation between equals. Archaeological evidence can't reveal the emotional reality of these ancient encounters. We don't know if individuals from the two species formed genuine partnerships. if violence occurred, or if most interactions were neutral avoidance. The genetic legacy tells us children were born, but not the circumstances of their conception or how they were treated. Contemporary debates about migration, cultural difference, and how society should respond to diversity take on different dimensions when we remember that humanity once included genuinely different human species. The differences between modern human populations are trivial compared to the gap between us and Neanderthals. Yet even that greater difference wasn't insurmountable. Somehow, despite everything, there was enough similarity for meaningful interaction. This suggests something fundamental about the flexibility of human social categories. Who counts as human? Who deserves inclusion in the moral community? These aren't fixed biological facts. They're decisions we make, boundaries we draw that could be placed differently. The rapidly improving image of Neanderthal capabilities reflects this fluidity. Earlier generations of scientists looked at the same fossil evidence and saw brutish primitives. Modern researchers examining identical materials now recognize sophisticated adaptations and complex behaviors. The bones didn't change. Our interpretations did, shaped by evolving ideas about what humanity encompasses. Future discoveries will undoubtedly refine the picture further. New excavation techniques, better preservation methods, and more sophisticated analytical tools will reveal details currently hidden. The Neanderthal story remains unfinished, constantly being rewritten as evidence accumulates. Some mysteries may never be solved. We'll probably never know exactly what Neanderthal language sounded like, if they had one. The full complexity of their social structures, belief systems, and emotional lives remains largely inaccessible. The archaeological record preserves only fragments, hints of lives that were surely far richer than the traces they left behind. What we can say with confidence is that dismissing them as inferior versions of humanity misses the point entirely. They succeeded for an extraordinarily long time in one of Earth's harshest eras. They developed sophisticated technologies, maintained complex social networks, and demonstrated capacities for abstract thought and compassion. Their extinction wasn't a failure of adaptation. In many ways, they were perfectly adapted to their world. What they couldn't adapt to was us. A different kind of human who brought novel competitive pressures they had no experience with. In evolutionary terms, they ran into simple bad luck. Another human species appeared that was slightly better at certain crucial things, and population dynamics did the rest. If environmental history had played out differently, if modern humans had never expanded out of Africa or had arrived in Europe at a different time when Neanderthal populations were stronger, the outcome might have been reversed. There's nothing inevitable about our survival and their extinction. It resulted from specific contingent circumstances, not from some inherent superiority. This perspective should generate humility about our own place in nature. We're not the pinnacle of evolution, or the inevitable endpoint of life's development. We're one solution among many possible solutions to the problem of being human. Neanderthals represented a different solution that worked well for hundreds of thousands of years before circumstances turned against them. The Neanderthal legacy challenges simplistic narratives about human progress. Their story isn't one of steady advancement towards some perfect form. It's a story of deep time, of populations adapting to changing conditions, of successful species suddenly facing unprecedented challenges, of survival and extinction. determined as much by chance as by fitness. Carrying Neanderthal DNA connects us physically to this other way of being human. Every person of non-African ancestry is literally part Neanderthal. When we look at human diversity today, we're seeing not just recent variations within our species, but echoes of older, deeper differences that were absorbed but not completely erased. This makes the story personal in a way that many historical topics aren't. The Neanderthals aren't just fascinating subjects for study, they're ancestors, contributors to what we are. Their struggle for survival in Ice Age Europe was successful enough that their genes made it to the present day inside us. What would they think if they could know their legacy? Would they recognize any continuity between themselves and us, or would the differences be too vast? Would they consider their absorption into the modern human gene pool as a kind of survival, or as extinction by another name? These are unanswerable questions that nonetheless matter. They force us to think about identity, continuity, and what it means for a people to survive or vanish. They make the distant past feel immediate and relevant. The Neanderthals remind us that human evolution didn't end in the deep past. It's an ongoing process that continues to shape us. The challenges they faced, finding enough food, adapting to climate change, maintaining social bonds, competing with rivals, these are eternal human challenges that remain relevant. How we tell their story reflects what we value and fear. Do we emphasize their differences from us, or their similarities? Do we celebrate their achievements or focus on their limitations? Do we see their extinction as tragedy or as natural evolutionary process? There are no wrong answers to these questions, but the answers we choose reveal something about ourselves. The Neanderthals hold up a mirror that shows us aspects of humanity we might otherwise overlook. In trying to understand them, we learn about the boundaries and possibilities of what being human can mean. They're gone now except for fragments of DNA and scattered remains buried in European soil. But they're not forgotten. Each new generation of researchers brings fresh perspectives and questions to the evidence. The Neanderthals continue to fascinate because they represent something essential about the human story, the knowledge that we're part of something larger and stranger than we usually acknowledge. In the end, studying Neanderthals isn't just about understanding extinct humans from 40,000 years ago. It's about understanding ourselves, our origins, our nature, and our future. They're part of our family tree, representatives of human possibilities that were realized differently than in our own lineage. Their story is our story, just told with a different accent, and it deserves to be heard.